Okay, so in this question, the combined lamina is a rectangle here, another rectangle there, and isosceles triangle, okay, as it states in the question. And they want you to get the distance of the centre of mass of the lamina from AG and AB. So if you think of AB as like the x-axis and AG as like the y-axis, okay? So then we look at each of these in turn, all right, and determine the mass's centre of gravity, and then do the same for the combined then lamina. So if I look at the, let's focus on the mass first of all, then the area. We call this rectangle 1. The area there will be 12 times 2, which is 24, okay, length times width. The area of this one then will be this rectangle here. Now we've got the width of 2, and that length there, well, it's not 8, isn't it? Because 8 is all the way across, so we need to subtract that distance of 2 from it. So actually the length will be 6, won't it? So 6 times 2, which is 12, okay. The triangle then, well, remember triangle is base times height divided by 2, so the base there is that length there, which is 6. The height is 6. So remember now, base times height divided by 2. So 6 times 6, which is 36, divided by 2, which is 18. Okay, combine all these together, then we'll give you a combined mass of all them added, so that comes to 54. Okay, 54, that's the combined total mass of the lamina. Centre of gravity, well, with the rectangle, it's going to be in the centre here, isn't it? Okay, so we're going to go across 1. Okay, cross 1, yeah, because that's half of the width there, 2. So cross 1 and up 6, yeah, half the height. So 1, 6. For the other rectangle here, well, we're going to go to the midpoint here. Okay, and of course we're already going across 2, aren't we? And then because the whole length is 6, we're going to go across 3. So 2 and 3 makes 5. Okay, and we're going up 1, yeah, because it's a width of 2, so we've got 1. The triangle then, well, the triangle, if you look at the isosceles triangle here, well, it doesn't look like it's been drawn to scale properly, but we've got here, it's going to be halfway across this length, isn't it? So it's going to be 3, I think that's 3 across there, and it's half the rectangle. Just looking at it, it's not been drawn very well, isn't it? Because that looks a bit longer than this. But they should be identical, because that's a line of symmetry. So that should be 3, that should be 3, but they're not drawn to scale, so we won't worry about that. So to get to the centre of mass of the triangle, if it's isosceles triangle, remember it's just 1/3 up here, okay? 1/3 of that height. Okay, so we're going to go across that distance there, which will be 5, okay, because 2 and 3 make 5, and then 1/3 of that, so I'll write that down, 5, and then 1/3 of this height of the triangle is, 1/3 of 6 is 2, so it'll be 2 up from there, plus that 2 here, so that gives me 4. So then I've got the centre of gravities for all of these, and then I'm going to do the centre of gravity then for the combined lamina, so x, y. So all I do then is take moments. So I take moments about AG to start with, which is like my y-axis. So I'm going to have the combined lamina, which is 54, times then the distance from the axis, which is x. That will equal then the rectangle 1, so it'll be 24 times the distance, which is 1, plus then 12 times the distance, which is 5, plus then 18 times the distance, which is also 5. Okay, so if I work that out, 54 x bar will be 24 times 1 plus 6 times 5 plus 18 times 5, so that'll be 174. So x bar then will be 174 divided by 54, and that will come out to be 3.2. Okay, 3.22 to 2 decimal places. If I do the same then, moments about AB. Okay, so we've got the combined lamina, as I said, is 54. Y bar this time for the height y, so that will be equal to then 24 times 6, 12 times 1, and 18 times 4. So 54 bar, y bar will equal all of them. So that comes to 228. So y bar then will be 228 divided by 54, which comes out to be 4.22. So that's part A answered. Okay. Now with part B, it says then the lamina is freely suspended from the point G and hangs in equilibrium. So it's freely suspended from here at point G and then suspended in equilibrium. Now if it's suspended from G, then its vertical line will basically be going that way, right? So it'll be going like this. Okay, like that. So that will be the vertical line if it's hanging there from G. And the vertical line goes through the center of gravity, doesn't it? Go through the center of gravity. So if you remember, the center of gravity was 3.22 across, 4.22 up. So it's about there, isn't it? Okay, that's where the center of gravity is. So I know that this distance here is 3.22. And I know this distance here, the vertical distance from there, is 4.22. Now I want what do I want? The angle. It doesn't say in the question, but they do want the angle, right? That forms with the vertical. Okay, that angle there. So if we have the angle, x there, well, we've got that side. We just need to get this side here. We need to work out this side here, which would be, if you think about it, it'll be 12 take away the 4.22. Okay, 12 take away 4.22. And then I've got myself a right angle triangle. Okay, so 12 take away 4.22 is 7.78. So I've got right angle triangle, I know that side, so then I can do tan x there will be 3.22 divided by 7.78. So then to get x, then I just do tan to the minus 1 of all of that. I get my answer to be 22.5 degrees.